Recording is in progress. Good evening, y'all. It is Tuesday, January 27th. We are Echo Platoon. Evenings and weekends. I'm your host, Jordan. Today, in week 5, day 2, we're going to be talking about class composition. Have we? Yeah, I think y'all covered inheritance already. Is that right? Or shake your heads no. Sweet.
Yeah,
Excellent. Tell me what inheritance is, Ken.
it's just when you have like a parent class and then you can create another class that basically inherits all of their variables or methods, but you can also modify them or add some if you'd like in another class.
Okay. Why would you want to do that?
Easier, less repetition.
Yeah, I like the repetition part of that. Easier sometimes. Some people find it real easy to just copy paste a bunch of code and just keep doing that, not to think about it. And that's great. But yeah, you're going to get a lot of extra lines. You're going to get a lot of extra code. And you build something like that and you got to go change one thing. Too bad. You got to change it 700 different places. So making things dry saves a lot of work, makes changes a lot easier going forward, easier to maintain, easier to find bugs, takes less lines if you're one of those JavaScript weirdos who absolutely cannot handle having extra lines. But today, we're getting a composition. And composition is a little bit, I would say maybe easier to understand. Basically, it's like inheritance, except there's not really any inheritance going on here. There is combining classes together that don't necessarily share properties, but do work in tandem. And that's what we're going to be working on today. So, class composition. And they made this lecture real cute and fun. If you like video games, if you don't, or you're not interested in this, sorry. It's I think it's cool. You've been hired by a video game developer to help them create their latest medieval fighting game. Y'all don't ever start creating a video game until you're way further on. It's a much bigger task than you can possibly imagine. But don't let me stop you. Go ahead and do it. Prove me wrong. They have some code for a previous game with classes for knights, offense and defense. If they want you to expand their classes to include 2 types of attacks ranged in melee, here's their current code. So let's take a look at this. Where are we at? Oh, don't look at all that. That's for later. We'll just put it right here. Cool. So, and probably a little smaller. Here's what we got. One import here from random import choices. You can go Google all the things that allows you to do, but for our purposes here, it basically picks one of 2 choices or other choices based off of you can feed it a probability. So instead of hey, pick one at random, you can say hey, pick one at random, but weight this one more. Pick this one 5 times as often as the other one, stuff like that. So kind of cool for probability. You can do that yourself. You don't need this library, but we're just showing you that there's cool Python libraries. So we have a class here called the offensive system. It instantiates with a weapon. And then it's got one function. Weapon probably needs to be a string because this function here, make attack, just prints attacking with self.weapon. Easy to understand. You plug a weapon into this and all it does is attack with that weapon. We've got a defensive system that is a little bit more complex, but not really that complex. We got a static method here, which I have to read in front of you guys because I forget it. Does not receive an implicit first argument. Cool. The heck does that mean? I have to look that up. I didn't do my homework. We'll come back. This is a decorator in Python. I don't know why this is doing anything for us. We'll get to it. So first, defensive system, we've got block and dodge. Block and attack, blocking or dodge and attack, easy to understand. These will, I guess, is just bound here. So for this function here, we've got engage defense. This is where it gets more complicated. We're using the choices library, and all it's going to do is do block. True or false. And here's the weights. We pass in a probability. This function takes a probability and is going to take that, and it's going to remove it from 1, basically. The choice is going to pick one of these. It's going to be weighted towards, I believe, true. And it's going to be, because it depends on what we're going to do, because if we called it by 0.7, it's going to be 1 minus 0.7. So true has a probability of 1. False has a probability of what, 0.7 less than that. So 30% of the time. If that's hard to understand, we'll make it make sense here in a second. And it just picks one of these one time. You can make it continue to roll through and pick a bunch of choices. If it's true, it blocks. Otherwise, dodge. Real simple. This is not a fun game. That's all it does. It either blocks or dodges. Then we got a class. Easy to understand. Knight. It is instantiated with a offense and defense. All it's doing is calling these other classes. We're not necessarily inheriting anything from them. We don't want to, utilize them, or rather, we don't want to take any of their properties, but we want to use them within our class. So truly, honestly, it's calling composition is all fine and dandy. For me, I don't know that it needs to be named anything special. I think it is perfectly easy to understand that within a class, you could have a value that is equivalent to another class. This is all object-oriented programming. We're saying within this Knight class, the variable self.offense is set to a class that we've already built up here. This object, this offensive system object, which is a class, and we're instantiating it with sword, and it's just got the defensive system. So that's the difference between inheritance. I don't have to say, hey, Knight, go get all of these things because these are going to be attached to you. No, we're going to be rather referring to those classes as variables rather than setting new variables, or rather inheriting variables into Knight. Knight has attack and has defend. So how we're going to utilize these, when we create a new Knight, what we're doing right here, we are able to reference these two variables. These, almost like a function, it's kind of like running a function, but you're running, you're instantiating a class. We're going to set offense to offensive system, defense to defensive system, so that we are able to say, or rather reference these things here. So for attack, Knight is going to have this attack function. What that's going to do is look at itself, look at this offense variable, which is basically the same as doing something like this. Within this class, we're pretty much just doing like O is equal to, offensive system and then, sword. We could be doing the same thing down here and it would work just fine. But if we want the Knight to have it, if we want to reference offense in regards to the Knight, this is the way you kind of accomplish that. You instantiate a class here. So offensive system needs to belong to a Knight, but it's not really something that's going to be inherited. So Knight dot attack is going to and invoke it is going to reference this function here, which is the attack function. It's going to look at itself, look at the offense variable, and then dot make attack. When we look up here, we're like, oh, where does this go? What does this make attack? Well, that's from the offensive system class we've got up here. And there it is, make attack. We didn't make this up. You just trace it back. So Knight instantiated, Knight.attack. Let's go look at Knight. Oh, there's attack. What is that? Self.offense.make attack, invoke it. Offense comes from offensive system. offensive system dot make attack should print out something saying attacking with self dot weapon, and we instantiated that with a source, so that should run. We'll talk about defend right after this. I want to go ahead and just show it real fast before we get too down the rabbit hole of me just talking. So if we run this, what happened? This didn't really do anything. It did instantiate an object based off the offensive system, but we didn't really call anything. K is equal to knight. We've got a knight class, and we told it to attack. This first bit it does here, not to make it more complicated, attacking with sword. So that works exactly as we kind of expect it to. The knight class is calling a function which calls this class. The make attack method within it, the offensive system was instantiated with the weapon we plugged in to the knight, and it makes the attack here. It does exactly what we kind of expect it to. For defend, we kind of saw what it did, but let's make this a little bit bigger. What is going on here? Where's my, oh, there we go. Okay, cool. So we got a good split. What this is basically doing is we're telling the knight to defend. So knight class has the defend function here with a block probability. We plugged in 0.7, which is the probability of blocking. So that's going to come down to about 70% when we do the math, but that looks about right. Look, most of these are blocking. We're saying this knight has a 70% chance of blocking. So just follow the logic. Knight.defend, plug in 0.7. Look at the knight class, look at defend. It took that 0.7. It referenced the self-defense instance variable and used engage defense with a block probability. We go up to the defensive system. Block probability is getting plugged into this engage defense as we thought. True, or sorry. So for the block, what we're going to return, our choices are true or false. And then we weight it. Probability of it being true is 1. Or sorry, 0.7, my bad. 0.7. This one of false is 1 minus the probability. So that's what going to be 0.3. So it's going to be weighted 0.7 to 0.3. Does that make sense? I feel like we got a lot more than that. So that would only be what? Just over twice as likely to see. If this is a 7 and this is a 0.3. We're all following this logic.
What is the 0 in brackets?
I believe that is going to let's just check real quick. When I was looking at this up, I really didn't want to look it up because it's kind of a silly thing to even put in here. I'd rather just do the math myself. I think if we were to remove that, true, false. What's this full logic look like? Oh, that is what it looks like. Let's just do 1. This object is strange looking. So I don't know what that's doing. Why did that not change anything, huh? Interesting. Does it look any different? What did I break? Oh goodness. I don't like doing stuff on the fly. Oh, I put it in the wrong spot. Oh, okay. So what's going on here is this is returning what looks to be a list, which makes sense. As I talked about earlier, this choices library returns a list. So if we don't take the 0 index of this, it'll still look like it's working. But I think you'll see that it's always, I don't know, Python's at least smart enough to figure it out. Evidently, list is able to iterate through it. Interesting. So look at this. This is not just true or false. This is true within a list. So we need to take the 0 index of it to get it to work properly. But evidently, we don't need that even because this if-else statement is still passing truthy and falsy for having a list with only a true or false in it. Evidently, that is fine. So more correct to take the 0 index, but evidently it didn't break anything if we, oh wait, yeah, it did. Yep, no, never mind. Disagree. Notice not a single one of these was dodging after I made the fix, I believe. We're gonna do that 100 more times. I mean, I think we should see dodging attack here at once if this wasn't working properly. Nope, they're all blocking. So, because choices returns a list of either true or false, right? It's going to return one of these. It returns a list with whatever is selected. We need to take the 0 index of it because it is a list with either a true or false in it. It creates a new list with either true or false in it. We need to take the 0. If we don't take the 0 index, it is always going to be truthy because it's just a list with the word true or false in it. But a list with a non-0 length is going to be truthy, right? Did I lose anybody there? No one's saying I'm lost. I'm going to assume that terrible explanation of me stumbling through it was adequate. Hi. So any further questions about this as we move on? Sorry, it took a little while to walk through what composition was doing here, but I might have beat it a little bit too much. I don't think this is a super complex problem after you've already dealt with inheritance. Moving along. So from the very get-go, we're supposed to be adding on to the code they already have. What we want to do is add some ranged and melee weapon classes. Should be fairly easy. It's not going to be much of a, it's not going to be much different from what we've already done here. We're probably going to create a new class and use composition to get it to do what we want it to do. This make attack, probably going to plug into here. Let's see if we're right. So let's add some of this code and talk about what it's doing. So everything below line 34 is what we've added. We got a new class here called melee offense. Takes a weapon, make an attack. Easy peasy. It's going to print attacking with this type of weapon, which is what we were doing before. But we've also got this little bit here saying from really close. The ranged is going to be exactly the same, but we've got a cute little output here saying you didn't even see my blank coming because it's a ranged attack. So that's how we're going to handle that. As you might have realized, if you've read ahead or if you just kind of been paying attention, we're repeating a lot of code here because we've already got this offensive system here that's going to be making an attack. So let's use composition to kind of figure out how we want to, sorry, I say composition. We're going to be inheriting. Let's go back to inheritance because These all kind of look the same, and we can use inheritance to build off of the offensive system. Note that melee offense, ranged offense, and offensive system all have the weapon property, not good. And that melee offense's make attack function is almost identical to that of the offensive system. Also, melee offense, ranged offense are types of offensive systems. So it would be natural for those two classes to inherit from offensive system. Here's a simple example. Review from yesterday. Parent class, child class. Parent has some properties. Method, this is method 1. Child is going to be initiated. Now instantiated is the word, with parent properties and its own new properties. We are going to super init with parent properties saying, hey, child, go to parent, plug in all this stuff I gave you, and then here are your new things, right? Parent doesn't have access to new properties, it's just got the old properties. Child method is going to say this is child method 1. Parent, wait, what am I doing? Oh, sorry. Anyways, so the parent would have this property here, property 1, child would have property 2, and I'm a child would be their second one. This is really simplistic, but parent is a class, child is a class, child inherits things from parents. It is able to access method 1, but is also able to do its own child method 1. Caveat, you do have to give child everything that parent needs if you're going to be inheriting, because parent can't get instantiated without the properties. So if you're going to be inheriting, you need to be plugging in everything that you're instantiating in child into the parent as well. Plus some, whatever else that parent doesn't have is not needed. But for sure, parent properties are going to be required. Using this framework, the child class inherits all its properties of parents, thanks to the super init parent properties, but also inherits all its methods. Yep. We talked about that. Sounds good. Does anyone have questions about inheritance before we move on? We move nice and easy and slow through this OOP, and no one gets lost. I like it. All right, so applying inheritance to simplify our game code, we now have the following weapon classes. Melee offense, which is going to inherit from the offensive system, as well as ranged offense, which is going to inherit from the offensive system. Offensive system, as we recall, doesn't really require anything to be plugged into it. It doesn't have arguments that it is going to, be instantiated from. It's just got weapon here. What we're saving space on is self.weapon is only going to have to be instantiated there. It's only have to be written there. We're not going to have to plug it into both melee and ranged offense. Saving some lines there. So melee offense, you're going to instantiate it using offensive system, and we're going to give it make attack. And all it's going to do is return print. Or sorry, it's not actually going to return. I want to play with that later. It's just going to print from really close, ranged. You didn't see that coming. Makes sense. It should still, when you do make this attack, let's see. Hold on, I'll scroll down too far. Sorry, I'm giving you a whiplash. We're instantiating this. Let me back up. Melee offense is just this. This is all of its properties. It doesn't have anything special that belongs to itself besides this make attack, which is kind of being copied from the offensive system here. We already have a make attack, kind of overriding it a little bit, the name, and using make attack from the original offensive system. So when we reference our parent, we can use super to do that, and dot make attack, which is going to be referencing the parent's make attack, which is named the same thing here. That's okay. I think it's kind of dirty, but that's okay. And it's going to print both attacking with weapon, and then from really close, really far. Let's see it all in action. All right. Back up a little bit so we can all see. Offensive system, our brand spanking new melee system, brand spanking new ranged offense system. Defensive system has not been touched. That's all the same. But when we run this attack, we're not going to look at defend for a bit because we're not really touching that. We are instantiating a knight here and telling it to attack. What has changed? We run attack as we always have. Offense. Now, though, instead of being the offensive system, now has the melee offense, which is inheriting stuff from the offensive system. Still going to instantiate it as we always have, but we do need to reference the class that we actually want. This is a knight. Evidently, knights use melee. Go up to the melee defense. Sorry, melee offense. We are taking our parent class offensive system, and all we're doing is rewriting make attack to reference offensive systems make attack, and then print our own. What this is going to end up doing is printing two statements, as I have said, attacking with sword from really close, because when we do this, attack is referencing melee offense. Melee offense is calling the parents make attack, and then it's printing from really close. So parent's going to print this, child is going to print this. That's why you have two statements. That's the order. That's the stack call in that. That's the not really a stack call. We didn't make a stack. We just kind of fired off two things. Do we all follow what's happened here?
So I guess long ranged offense would say would also print two things, attacking, but then it would say you didn't see my weapon coming.
Yeah, I probably should do that. Let's create well, shoot, let's replicate some stuff here. And you're thinking, oh my God, you're replicating. Yeah, if we were going to be doing something like, if I were to add in something like this, we probably should inherit some stuff, because right now you're seeing archer and knight both have offense and defense. So right off the bat, it would make sense to be like a, I don't know what we'd call it, but like character. And the character class would have offense and defense, and then archer and knight would bring that in. The only difference is they've been instantiating their type of weapon. So we were to say an archer as a bow uses ranged offense. Everything else should be the same. A equals archer. Okay, so looks good. Hide that away. Ooh, why are we only getting one? Let's follow that. Do this right. Give me a second. Oh, yeah. Well, look right here. So if we look at the melee offense, when we call make attack, this one is referencing its parent, and then it's doing its own print. Whereas the ranged offense, it's just doing its own print. We could plug this in here to call the parent and do the exact same thing. That's just evidently not how we want to do it. So if we were to make that one quick fix, then yeah, attacking with bow, you didn't even see my bow coming. Looks good to me. However, the reason it didn't do that, it seems, is that in its print statement, they tell you right then, hey, this is the weapon we're going to be using. But just to showcase, hey, you can reference the parent, the parent functions, but you don't have to. You're not gonna make calls to parents if you're not, just because you're instantiating. We only use what we need. Any questions about all that? Cool, cool. How long have I been recording? Oh, yeah. Okay, cool. What I want to do next is talk about testing a little bit. Did Chad go over unit testing in Python on Saturday?
Yeah, he talked about it a little bit.
How do y'all feel about unit testing?
It's not fun.
Yes, it is. No lie. Did he cover TDD, test driven development? Do y'all know what that is when I say that?
No, he did like the thing where you import unit test, and then you have to write each of the methods within the class with the starting with test, and then at the bottom, it's something like if main equals or something along those lines.
Right.
I do think you actually mentioned it a little bit. Just like, you mean test-driven development is in like you write your tests first and then you just like continuously test your code, and like as it passes, you write more code?
Yeah.
Or like I know he kind of brought something along those lines up because we were starting with like, is this class even a class? And then we would like write more code and then kind of expand from there.
Right. Yeah, so that's kind of the process of TDD. We, as a organization of Platoon, it used to be very much part of this. This is the first cohort where we're not forcing TDD down your throat and saying you will do it, you must do it. That's what we teach. Platoon alumni use test-driven development to develop. I think there is a version to it, and right off the bat, you're saying it's not fun or it's not really sure what's going on, and that's fine, because you guys are learning how to code and doing these assignments. You're really just trying to get it done, right? And you're trying to learn the new things that we're teaching you, and you're trying to make use of them. Test-driven development for a newer developer, especially if you're not in the habit of doing it, really gets in the way, right? It slows you down, and it's one more barrier that you're fighting against. And I understand, where you're at right now, and maybe thinking that this sucks, and I agree. And that's kind of why we've taken it out of the curriculum. However, I'm not lying when I say every single time I have started a project on my own that I have really wanted to, be consistent with, really didn't, trying to be, I guess, deliberate about it. I've used test-driven development. Reason being, it is such a pain if you code for 12 hours 1 week, come back 2 days later, and you don't know how anything works, or you got to debug your own code. Or let's say you're working on your own project, got 40 hours in it, someone else comes in and they break it and they have no idea how anything works, and it's not as easy to return to look at code that you didn't write. And code you didn't write could be code you wrote a week ago. I mean, that's usually it's like a completely different person, right? If you wrote code a week ago, you may not even know what it is today. If somebody else writes the code, super duper hard, and it's really it's a mark of kind of a senior developer to be able to jump into code they don't know and very quickly organize themselves. Having tests is very helpful for that. It's very helpful for allowing other people to make changes to your code. And test-driven development ensures that you've got tests written as you're going. Writing tests after the fact is fine, and it's good, and it happens a lot, but how much are you testing, right? And what are the tests really doing? When is enough tests, when is enough? And how do you know that you've kind of tested everything? What if you forget that you've got bugs in your code? Doing it on the front end is not necessarily a way to, prevent you from having no non-tested code whatsoever. However, it's a great way to start. It's like pseudocoding. It's better than pseudocoding in a lot of ways, because you're saying right off the bat, hey, this is what this is going to look like when it's correct. And then you write the code for it, and then the test pass, and it looks really, clean as you go. I'm really quickly going to run through how I set up my own, personal projects, or even at work. If I hop onto an app that doesn't have tests written, or has tests written poorly, anything I add to an application, I'm writing tests for, because I'm pushing something out to production. No super senior developer is just going to be like, "Hey, does it work, Jordan?" Yeah, okay, good. They're like, "No, show me some tests. Show me what you've done. Show me that it does work and it does do the thing that we need it to do." When I'm tasked with fixing something, they don't just show me a ticket and say, "Hey, go fix this," and I tell them when it's done. I rate a test that would pass if this was working properly, and then I go from there and work on the code. So forget we did this, because we're going to test drive that a little bit. Let's move this to somewhere else. Oopsies. What's going on with me? Okay. Close everything down. Got a brand new one right here. Looks great. This is our code. We just moved it to a new place. Don't freak out. It's just this right here. God, I hate that search. It's just a folder with this lecture.py. If I wanted to write tests, so should have done this ahead of time, but I'm going to go ahead and set up the test for testing like a night or something. The way I like to do this is, some people will just like slap something here, test.py, and they'll just write the test right along with it. So then you got lecture.py and test.py, but I've got something else like, well, this is going to be like night.py, and this might look fine to you, but I personally hate this. I don't want to see a bunch of files in one directory. I want directories to make sense, and the things that are in the directory should, the directory name should be inclusive. I don't want to see project in the next level, every single file in the project. That sucks. Split things up into directories that makes sense. With unit tests, I'm going to create a directory that I'm just going to call unit tests. So, and I'll get rid of night if I'm doing that. So now I've got the lecture, but I've also got unit tests for it. Not plugging anything in there just yet. Or will I? Yeah, let's go in there. So within unit tests, we have nothing. Let us create a spec file. So I want to make sure that my night works. So I'm going to use night spec.py. This name is important. This dash spec is important for the unit test library to work as you'd expect it to.
Do you mean the spec part, or like the part reference in the night class? For the name?
The night, not really important. Dash spec.py is important. And
Gotcha.
we'll go into why that is. Some of these names make sense, some of them don't. How do you remember which ones? Well, you'll know because they just won't work. And read the docs. Let's do this. We're going to import unit tests, and from lecture import night. Why am I not doing something like this? Because I have to go up one directory? Well, I'll show you. Because I'm not going to be running this unit test at this level. So I'm not going to go into this and then do Python night.spec, because that's not going to work. It's going to say, hey, I don't know what lecture is. Do we all understand how imports work in Python, by the way? Have we covered this? Does this blow your mind? It drives me a little nuts, but when you get into JavaScript, importing is relational, of where the file is. So notice within here, there's just night.spec. If we go up one, there's lecture.py. If this was JavaScript, we would want to go, hey, go up one and then go find lecture.py. If I was running from here, this would also need we need to like go up one. Well, going up one is very difficult in Python. We have to import some, hey, by the way, you're not where you think you are. Python is from where you run it. So if I wanted to run night spec, I would actually do it from above like that. And that's still going to be not working the way I want it to, but we'll come back to that. But that's where I intend to run it from. Let me finish the test and I'll show you kind of how I want to do this. Module name lecture, I'm pretty sure. Okay. Continuing on. We are going to create a class called test night. I believe this is required. You do need to call these things tests, and reason being, the unit test library goes through, reads a file, and is going to know to run functions based off of their names. It's going to be looking for these real quick. Oh my God, Ben, don't do this to me in front of everybody. Based on it real quick. We've got this test attack method. So when this file is run, it's going to go look within here and run all of these functions with word test. All it's going to do is instantiate a night and then set assertion of equal night.attack is going to work, or when it works, it needs to equal from really close. So we've created night, which is this class, and then I'm invoking the dot attack. Just pull this over here so we can look at what we're talking about while we're doing it. You're going to be running the dot attack method from night. And I'm saying, hey, if this works right, I expect it to say from really close, right? What, however, this is probably going to fail, I'm pretty sure. So let's see. Yeah. This is what we're going to need to run. So I'm going to need to run Python module unit tests. Discover is saying, hey, this is where the unit tests are. This is what I want you to go look for them. I'm using the module unit test. Discover unit tests here is going to be the directory unit tests. We could call this directory tests if we wanted. I like to keep it, I like to reuse unit tests whenever I'm talking about Python unit tests. And then we're saying, hey, every file in there, *_spec.py is what I want you to run. Main A is not defined. Oh, get that out of there. Cool. So I ran my unit test. That used a Python module unit test. It went looking in the unit test directory, which is right here, and it looks for files specifically that match *_spec.py. So it went into my unit test directory, found night_spec.py, imported this lecture night in, instantiated it, and ran a test. And notice what happened here. Assertion error, none. None is not equal to from really close. Why is this none? Does anyone know? Looking at what we've got going on over here.
Is it because we don't have the offense, the other objects that we're composing for the night class imported in as well?
No need.
Okay.
No need at all, because we're to interact with them directly, we would have to do that if we wanted to test them. I'm only testing the night. Night knows how to go get them and reference them. It's the simple thing that you guys run into all the time. Probably not so much anymore, but definitely when you're new coders. I'm just printing. I'm not returning anything. So if I want to get something back, I need to return it. And I don't know if I want to do it here. Let's do it down here in the actual class. Well, it's going to have to print something. Yeah, so I'm going to need to either. Yeah, this makes sense. We're just going to here return from really close. So when we call this make attack, it will print it, and that's fine. But I want to return also. Yes. Failure, none. From really close. Still not working for us. And I
Is
have to
it the
remind
parentheses?
myself. Parentheses shouldn't be bothering us. I need to remind myself real quick what else I fixed, because this we need to set ourselves quite up for this. Oh, again, we're just
That's
calling.
only worded night and not the class that you're taking the make attack from.
We need to do both. Because this needs to return a string. And we can get rid of those. It doesn't matter. Wrapping something in parentheses just scopes it in. We need to return this string, but just calling self offense, that's not really returning anything. It's just doing it and not giving it back to our original call. So adding a return here ought to get us there. Hey, look at that. My test ran. And you see, because I left that print statement in there, it's still doing this attacking with sword from really close stuff, but that's not really anything to do with my test. Those are just print statements. If we don't want those in there anymore, we can do that. They're not really helping us, with anything. So get rid of from there. And then we don't really need that anymore. Oh, did I break it? What did I do? Oh. Well, yeah, wait a minute. Okay, I'm not gonna take that out, but because what I would have to kill this, and that would cause some problems for all of us. So my test ran. It looked good. When I called night attack, I got from really close back. Does everyone follow what I've done there?
Yeah, would a workaround, like if you have a method that just prints, would it have worked if we did print night attack instead of just night attack?
Are you talking about in the tests here?
Yeah, like before you changed it to returning and we had the prints, like if we actually put a print statement in the first argument of assert equal, like would that still return the string and make them equal?
I don't believe so. I don't think you can capture a print statement. A print prints to the
Okay.
terminal. As far as Python's concerned, it spits to the terminal and it cuts it out. There's not a really good. There might be a way to capture that object, but I don't want to do that. That'd be kind of goofy. Let's test the returns, test that it's working kind of as we expect. So I am going to. Yeah, go ahead.
So yesterday, like on the apple tree one in the spec test, it seemed like they did almost like an iterative test. Would you be able to do something like that as well in this with like 5 attacks? I know for like the attacks it doesn't make as much sense, but when we get into numbers, then you can test different like groups of numbers, if that makes sense.
It'd probably be as simple as that. And then we would probably do something like self dot tax dot append. Oh wait, let's
I
do
guess
my
maybe a
stuff.
better explanation is like can in the like the testing in the spec file, could you make it try like 5 attacks and make sure each attack always prints the from really close or
I think so. Yeah,
uh,
let's take a shot. So did you see what I've done over here? I've
Oh.
added attacks to the knight, and when I attack, I'm going to continually add to this when I iterate. So I want to write a test for that. I'll do something like test attacks. We can instantiate knight again. And well, should still that too. Self assert equals knight dot attacks. Length. I want to see it. I want to see it attack 5 times, right? So it's working out the way I think. Oh, it did. So I could knight dot attack. Let's just do it 4 times and see what happens. Int has no length. Oh, length. Duh, that's right. I didn't. Oopsies. So I real quick pulled out knight and I attacked 1, 2, 3, 4 times. Assertion error. 4 is not equal to 5. Well, let's add another one in there. Hey, that works as expected. Easy peasy, right? We kept that we kept the object alive. We're still iterating it. This is still this same knight, and we continue to work that object within the scope of this function. Cool, right? I think so. Let's test drive or test develop something real quick. So we talked about an archer earlier. I want to make an archer. I'm not going here to do it. That's not test-driven development, y'all. Instead, within our unit tests, let's just create a new one. So copy, let's call it the archer spec.py. Let's open that up. Notice it looks exactly like knight. What are some quick ways we can fix that? I'm going to get rid of that just for simplicity's sake. Knight. This is archer now. Let's make sure that's lowercase. That's lowercase. Otherwise, sounds good. From really close, we probably need to update that. What do we want it to say again? You didn't even see that coming. In fact, I don't want to do that. Let's just say foobar. I don't know what an archer is going to do. It doesn't matter to me. I want it to return foobar. That's what I've decided is going to be correct. So no matter what, I don't care. You know, I haven't thought about the testing or the code at all yet, but I've decided what I want it to look like when it's working right. So this is my test. Let's run my tests. Yeah, there. My unit. Reverse search does not work on this. I'm sorry. I need to fix that. Cool. So we ran 3 tests, but we failed one. Cannot import name archer from lecture. Oh, well, shoot. We don't have an archer. All right. Thanks, Mr. Test. Let's create one. All right. I'm just going to change it. We've got an archer now. Run it. Uh-oh. All right. Well, that worked, but from really close is not, you know, foobar. Let's look at archer. Well, it's not doing exactly what we want it to do, so we probably, you know, should make this ranged offense, and we're gonna, you know, do a bow. And without looking at really, you know, anything else from there, let's get rid of that. I don't really need this anymore. What was my? I'm sorry, I'm just deleting stuff. What was my test? I wanted it to say foobar. Well, instead of all this nonsense, well, I'm not telling you to fake your tests. I'm just, you know, giving an example real fast. I don't want to waste too much time with this. I just want this to say foobar, not the other foobar. Hey, my test works. Great. I created an archer that returns foobar when it attacks, and I base that off of this test-driven development, right? I don't have to go test anything now. Well, I mean, I could write some more tests. We could have talked a little bit more like, hey, an archer should have a you know, a weapon called a bow. It should have this. It should have that. You know, these different things. and I mean, we could test that too. Again, self.weapon, we could look at self.offense.weapon should probably be, you know, whatever we feed it. We can do things like that. In fact, we will, but I want to show you all something real fast that I can explain in more depth after this, but I'm going to talk about it in the lecture, so it's recorded. You can go back and look at it, but I will share this with you. This bit here, running this thing after every little change you do, does anyone enjoy doing that? Or would you rather it just kind of take care of itself? There is a tool, there's a lot of tools actually, a lot of tool or testing framework or testing tools. I use something very simple. It's not even really a testing tool. It's called ENTR. It is just a basic cause and effect bash action. I'll explain it. Basically, run arbitrary commands when files change. ENTR, I can point at a file and say, hey, when that file changes, do something. An easy way to do that is to plug a script into your stuff. So I'm gonna real quick create a file. I'm gonna call it run tests. Notice permissions on this are read, write, read. I can't execute anything. Why am I talking about that before I showed you? I don't know. But this is what it's going to look like. And this is kind of the template that I'm going to plug in here. So this is saying, hey, run bash in this file. You know how this Python shows up here that's nice and clean and cute? That's VS Code interpreting .py, and it knows what to do with it. I don't have to have a .py. That doesn't do anything. It just helps the computer kind of understand what it's looking for. This file is just called run tests, not run tests.bash.shell.text. I just called it whatever I wanted. At the top here, I'm saying, hey, when you read this, execute it with bash. And what this is called a shebang. This is looking in the bin directory in the bash, you know, executable, which is right where it should be. Yep, user level bin bash. It knows all that. This not super important. I just like to plug in there that I'm in a test environment. That can be helpful later, but let's not worry too much about environment variables until we actually need those. But here's that same line I was running earlier, right? It was that Python 3, you know, module unit test, discover unit test, spec.py. And then I've got some helpful text here for me. Use ENTR to rerun tests upon changes to files. The way that looks is you hand it files, you pipe that into ENTR with an S, and then you can give it a script to run, or commands by itself. I'm going to feed it this script. So what that's going to look like is actually just ls star.py entr-s and then run tests. Why is that not going to work? Because again, run lectures is not executable. I need to execute it. Change mode of operation to all. Actually, let's just do users plus executable run tests. Notice it turned red, and now the user squid can execute this file. Let's make sure that's a real thing. Oh my Lord. Cool, that ran as I expected. But using ENTR, it needs a list of files. LS is going to create a list of files right here. It's going to get all the files that end with star.py. So it's going to feed it lecture. This is a pipe that's saying, hey, whatever that command is, feed it to this next thing, which is going to be entr-s. S is going to be basically, hey, I want you to run this. This is what you're going to run next. And I want it to run that run tests bit here. Notice my terminal is frozen. It's not doing anything. Why is that? Well, ENTR is watching this file right here. It's watching lecture.py. So if I make any changes to this, it should rerun, some tests, ideally. Let's break something. We'll remove the A and save. Look down here. I just failed the test. Let's say we're 15 hours into my coding and I just, you see me do it, make a few mistakes now, and I just screwed something up and I don't know what happened. Immediately a test is, has failed. I can just fix that real quick. Look at that, tester passed. If we want to use test-driven development, we can create tests that fail and continue to develop on them until they pass. I like this workflow a lot. It makes test-driven development not feel like so much of a pain. I know all this setup might be a little intimidating, but literally all you guys got to do is take this run tests, save it. It's a template, plug it in somewhere, and all you're ever going to have to do is execute it once you point it, kind of where you need it. And I've got these notes in here for me, which you can, leave notes for yourself. So we're getting about an hour into this lecture. I just want to real quick display what this does again to run that at home. What's a good test for an archer? We want to see the weapon type, right? We talked about that. So define test show weapon. I would like to see a function in the archer's class that shows me what kind of weapon it has. That's all I want to do. I need a function in there that does that. So in here we would shoot, why do extra work, copy paste, easy peasy. Instantiate a new archer dot offense. Oh, actually, yeah, we'll just call it show weapon. And I want it to say bow. Archer is therefore going to have to be instantiated with a. Oh no, it'll have whatever is over here. Cool. Not supposed to be looking over here, but basically I want it to say bow, right? In fact, that's not even true. I want to say let's say like a spear, like a huffing spear. I'm not going to misspell this in front of everyone, am I? Is that right? That seems right. Yeah, this archer has a javelin. Let's do a crossbow. All right, we're messing around. This is not updating because I don't have it watching the tests. We could tell ENTR, hey, when you're writing tests, start making them fail. It doesn't know what to do with that yet, so I'm gonna have to rerun this. By the way, I hit Control-C to get out. If you're ever stuck in a loop, Control-C. If you want to kill the terminal, Control-D. So we're back in it. Notice we got 4 tests now. One's failing. Archer object has no attribute show weapon. Well, let's go over here and create that. We deleted that, save the file. Oh, it's still broken, Jordan. Show weapon. Still failing. This gave us foobar back. Oh, it's returning foobar. Let's return offense.weapon, right? Oh, self.offense, my bad. Again, if y'all aren't paying attention super close, just reminder, offense reaches back to this ranged offense class here, which does in fact have a weapon. We're instantiating it here with bow. So that ranged offense has an instance variable called bow. But this is still failing. I wanted a crossbow. Well, that's fine. I'm just going to say, hey, this archer, he has a crossbow. My test is passing. I've got tests written. They were written fast. I don't have to go back now and be like, oh, no, what do I need to test defend now? We got to learn, which I do have to because I didn't write ahead of time. But are y'all picking up what I'm putting down? You'll smell when I'm stepping in. Does anyone think that sucks a little bit less? And I kind of understand how that can be helpful. I'm not saying any of you need to do this ever. I am, as kind of a senior dev to y'all, telling you This is a really good work practice. This is impressive to people. You pull out ENTR and write up a script. Yeah, I'm gonna record this because I'm getting on a. I'm always gonna step up and start, talking about this crap. I've done a lot of interviews, and 99.9 times out of 100, like everyone, when you say, all right, here's the code, write it, they're going to open up a Python, JavaScript, Ruby, whatever the heck file, and they're just going to start coding, maybe using print statements, probably not, and they're just going to fumble through their code. Imagine if you said, all right, cool, yeah, what do you want me? You want me to create something that says hello world? All right, real quick, I'm going to just create this test file, and it's going to run these unit tests. I'm going to create a unit test real quick that says test hello world. I want to, when I run this file, get hello world back, or this class, I want to say hello world. You write your test for it, cert equals, great. You write another test that says, hey, this test is going to fail if it doesn't, have two letters or whatever. And then you go write this. Did you eat a lot of time during your interview process? Not that much. You maybe use like a minute if you really know how to do this off the top of your head. Did you show that, hey, I'm going to write code and test it right in front of you? I'm familiar enough with tests. I might be a junior developer, but by God, I know how to write tests. I think they're important, and I'm not going to turn in code that doesn't have tests written for it. You are going to look so god dang impressive. And you didn't even do anything. You're literally doing the same thing everyone else is doing. You just do a few steps ahead of time. And as they ask you more questions, as the code develops, you're writing out tests for it right alongside it. That is not just, flexing that you know how to write tests. That is somebody they want to work with, right? Nobody wants someone to come in, sit in a corner, write code that no one else understands, no one else can work on, that they have to explain. And when they leave, it's now code that someone else has to maintain. Show that you can do this kind of stuff, and it's going to be a big deal to somebody at some point. You don't have to do this throughout the whole course. If you do just one or two of these for each of your assignments, just to get in the habit of it, I think it's very useful. I'm going to share all this work so that you guys can, just do this. And I would like you to do it with the assignment today. In fact, you're going to do this with the assignment today because I think it's not going to take you that long. Are there any questions about composition, inheritance, object-oriented programming in general, or Python unit tests? Or any of the stuff in between that I showed you with this bash? Cool beans. I'm going to stop recording now.